In the 1980s and 1990s, betting on horse racing made Bill Benter rich. Really, really rich. To the tune of $1 billion. And he won it fair and square too. You see, Benter was obsessive. He collected vast amounts of data on every variable imaginable. Its weight, age, sex, recent form, the going, the jockey, the trainer, the list goes on. And by constantly refining his models, Bill managed to find something incredibly valuable. A 10% edge over the rest of the market. But once he'd done the hard part, one question remained. How much should he bet? You might be wondering why an investment channel has suddenly wandered onto a racecourse. Fair question. But stay with me, because the problem Benter was solving turns out to be an investing problem too. And by the end of this video, you will know exactly how much of your money any single good idea deserves. I know betting odds can be a little confusing, so let's slow it down for just a moment. If a horse is priced at 4 to 1, every $1 you stake returns $4 in profit, plus your original dollar if it wins. Now those odds imply that the horse has a roughly 20% chance of winning. Strictly speaking, bookmakers build in their own profit margin, so the odds aren't truly fair. Bookmakers are many things, but charities they are not. Still, let's pretend the odds are fair for now. Bill, however, has done his homework. His model suggests that this horse is actually going to win 22% of the time, not 20%. That tiny difference is all he needs. It gives him an expected return of 10% on every race he chooses to bet on. Now, everyone instinctively knows it would be madness to bet his entire bankroll on every race. One loss and he's wiped out. Betting 25% each time feels much safer, and indeed, he does survive much longer, around 60 races on average. Drop that to just 10% per bet, and his survival jumps tenfold. But now something interesting starts to happen. After 1,000 races, someone betting 5% of their bankroll typically finishes around $11 ahead of where they started. So we've solved the problem of going broke, but we've not exactly made Bill rich. We could keep trying 4%, 3%, 2%, and then simulate another 1,000 races each time. But there must be an easier way to find the fraction that grows his wealth as quickly as possible. Fortunately, there is. And this problem was solved in the 1950s by an engineer called John Kelly while working at Bell Labs. He discovered a surprisingly simple way to answer one deceptively difficult question. If you have an edge, how much should you bet each time to grow your wealth as quickly as possible over the long run? His answer became known as the Kelly Criterion. Instead of testing one fraction at a time, Kelly looked at the long-run growth produced by every possible fraction. Bet nothing and obviously your wealth goes nowhere. But bet a little and your edge begins working for you. Increase the fraction and your long-run growth rises, but only up to a point. Because as the bet gets larger, those violent swings begin eating away at the advantage. And by the time we reach 5%, we're already close to where we started. The best fraction sits right at the top of the curve, 2.5%. This isn't just another guess from our simulations, it's the fraction that mathematically maximises Bill's long-run growth. But why 2.5%? At its simplest, Kelly says this: the optimal fraction to bet is your reward divided by your risk. Let's leave that formula hanging for a moment and unpack what those two ingredients actually mean. First, reward. For a fair 4 to 1 horse, you lose your stake around 80% of the time and win 4 times your stake the other 20%. On average then, for a fair bet, you break even. Bill's horse is different. Because his research tells him the horse is going to win 22% of the time, he now expects to make around 10% on every race he bets on. That's his reward. Risk is a little less obvious. Kelly measures risk using something called variance. Don't let the name put you off, it's simply a measure of how wildly your returns swing around from one race to the next. A 4 to 1 horse is a fairly violent bet. Most of the time you lose your stake, but occasionally you win 4 times as much. So the experience is less steady accumulation of wealth and more repeatedly being slapped with the occasional apology. Those large swings give this opportunity a variance of roughly 4. Variance is easier to see than to define, so let's run 100 races at fair odds and see where they land. Most finish somewhere near the middle, but the tails stretch a long way in both directions. That spread is the variance. Now give Bill his edge and see what happens. The whole distribution shifts to the right, but look carefully at its width. It hasn't really changed at all. An edge moves where you expect to finish, but it says nothing about how violent the ride will be. So now we have everything we need. Bill's expected reward is 10%. His risk, or variance, is about 4. Divide one by the other, and there it is again, 2.5% of his bankroll. The same fraction we found at the top of the curve, now reached without simulating another 1,000 races. Before anyone reaches for a calculator, one warning. Kelly's answer is only ever as good as the 2 numbers you feed it. Bill spent years building models to earn that 10% edge, and even he was estimating. Your edge and your variance are a guess, and a formula this confident will happily take a bad guess and size a bet around it. In other words, the formula may be precise, but the numbers we feed into it are not. That makes Full Kelly extremely sensitive to bad assumptions. Remember the shape of the growth curve. If we bet slightly less than Kelly recommends, we sacrifice some potential growth. But if we bet too much, the punishment is far more severe. The curve is asymmetric. Underbetting costs us a little, but overbetting can destroy us. And that's why many investors use fractional Kelly instead. Rather than betting the full amount suggested by the model, they might bet half a Kelly or even quarter Kelly. In our example, the full Kelly recommends 2.5%. Half a Kelly would therefore mean betting 1.25%, and a quarter Kelly would mean betting roughly 0.6%. Yes, the theoretical growth rate is slightly lower, but the portfolio becomes far more forgiving when our estimates inevitably turn out to be imperfect. Fractional Kelly is essentially mathematical humility expressed as a percentage. So Kelly's answer was never really a number, it was a discipline. Your edge tells you whether to bet at all, Kelly tells you how much, and fractional Kelly admits that you might be wrong. But Bill Benter didn't become a millionaire or a billionaire betting on one horse. He found thousands of opportunities and backed them all at once. Which raises a harder question. When does owning more things genuinely reduce your risk? And when are you just making the same bet under different names?